Okay, so we're going to do one more example here before we move on to a different type of example in your homework. And this involves solving trig equations. Okay, so um, for part C in this problem right here, I have 4 sine x times cosine x is equal to 1. And you might be tempted to move the 1 over, and that wouldn't be a bad strategy. Okay, or some of you might be dividing by 4. You don't want to use the constant product rule. There's no such thing. And I want you to see that sine x cosine x, right? That should remind you of your double angle formula. So I'm going to write it out here on the sine. Sine of 2x is 2 sine x cosine x, right? And so we have the sine x cosine x on this side, but we need a 2. So I'm just going to manipulate this by rewriting as 2 times 2 sine x cosine x is equal to 1. Okay, well, in the previous problem, right, in part B, I kind of expanded it, right? This time I'm going to condense. 2 sine x cosine x is just sine of 2x. So 2 times the sine of 2x is equal to 1, right? This goes to this. And now I'm going to divide both sides by 2. Right? And actually, this is just the multiple angle formula, or multiple angle equation, I should say, right? Let theta, right, equal 2x. And you've done problems like this before, right? Sine of theta is equal to 1/2. And then you just have to have knowledge of the unit circle, right? So theta is going to equal to pi over 6 plus 2 pi n. Or sorry, theta is equal to pi over 6, or theta, where else is sign positive? It's also positive in quadrant 2, 5 pi over 6. And you want to write the general solution, right? So theta is going to equal to pi over 6 plus 2 pi n, or theta is equal to 5 pi over 6 plus 2 pi n. Okay, so you're almost done, right? The last thing you need to do, right, is to remember that theta is actually equal to 2x. So substitute it back into here. If you get x by itself, you're going to get pi over 12 plus pi n. Do the same thing for this guy right here. And if you get x by itself, you're going to get 5 pi over 12 plus pi n. Okay, so this would be the general solution to this equation. Okay, so for part 1, the key on this problem, right, is to condense it and to recognize that you need to use a double angle formula substitution and call it sine of 2x. And actually, there's a problem in sections, I believe 27 through 30, that asks you to condense it, to rewrite it in terms of a double angle, right? How do I rewrite 4 sine x cosine x? I could rewrite it as 2 sine of 2x, and that's basically the strategy or technique you want to use. Okay, so we need to finish this problem, right? We still have to find the solutions on the interval from 0 to 2 pi. And that becomes a little bit easier. All we have to do is substitute n values starting at 0, okay? So if you plug in 0, right, you're going to get pi over 12. That's definitely in the interval from 0 to 2 pi. If you plug in n is equal to 1, pi plus pi over 12, well, that's 12 pi over 12. That's 13 pi over 12. That's still in the interval. But if you plug in n is equal to 2 pi plus pi over 12, that's going to be outside the interval. So we're going to stop right here. These are the two solutions within this section that's within the interval from 0 to 2 pi. So plug in n is equal to 0 on this one, you're going to get 5 pi over 12. N is equal to 1, you're going to get 17 pi over 12. And you ask, is 17 pi over 12 in the interval? Yeah, this is 1 and 5 twelfths. 1 and 5 twelfths is definitely in the interval from 0 to 2 pi. And again, if you plug in 2, right, 2 pi plus a number bigger than 0 is clearly going to be outside of 2 pi. So this is these are all the solutions in the interval from 0 to 2 pi. Okay, so for a problem like this, just a reminder, sometimes you might need to condense it and rewrite it in terms of your double angle formula going from left to right. And on the previous problem, you'll notice that I expanded my double angle formula. And that's why trig equations get a little bit tricky, right? Every problem, it just depends. And you kind of have to get creative with it in terms of manipulating as long as you don't violate any mathematical rules or principles. Okay, let's do one more problem on the double angle section. And I'm going to move up here, and these are just one of your quadrant problems. And typically these quadrant problems are fairly straightforward if you know how to sketch the triangle, right? By now, hopefully all of you are comfortable with sketching it. And so let's finish up this problem here. All right, so we're given that cotangent of theta is -5. Theta is in quadrant between 3 pi over 2 and 2 pi, so that puts us in quadrant number 4, I should say. And we're asked to find the double angle, the sine, cosine, and tangent. Okay, so let's draw our triangle here first. Our quadrant 4 triangle looks something like this, right? This will be your theta. And if you remember, right, cotan of theta is, tangent is y over x. Cotan would be x over y. Put a 1 underneath over here, right? Now, what am I going to do with this negative? My negative, I'm not going to stick on the x, right? I'm going to stick on the -1 because I'm in quadrant 4. Okay, so if you were to label your triangle, right, this value is 5. This guy right here is -1. And then this one right here, you just have to solve for what your r is. So using Pythagorean theorem, right, r squared is 5 squared plus -1 squared. R is the square root of 26. Okay, so your triangle, all 3 values are found and labeled, right? Your x is 5, your y is -1, r is root 26. Okay, so let's find the double angle of sine first. Sine of 2 theta is just 2 sine theta times cosine theta. Right, and now all you have to do is just plug in what sine theta is, right? So sine of theta, right, I know is y over r. My y is -1. My r is root 26, so -1 over root 26. Cosine of theta, right, I'll just do it here on the side, is x over r, 5 over root 26. Your r is never negative. Right, and you don't need a calculator, right? You can just simplify this. 2 times 5 is 10. Root 26 times root 26 is 26. You're going to get -5 over 13 as your final answer. Okay, so do the same thing for cosine. Maybe here, I'll do it here on the side. Now, for your cosine double angle formula, right, you kind of have a choice which formula you want to use. It doesn't really matter which one you want to use. I'm just going to use the first one. Cosine squared of theta minus sine squared of theta. And you already have these values, right? So 5 over root 26 squared minus -1 over root 26 squared. Okay, so simplify that. You're going to get 25 over 26 minus 1 over 26, which is 24 over 26, which reduces to, if you divide top and bottom by 2, you're going to get 12 over 13. Okay, so the very last one is the tangent one, and this one requires, I guess, a lot of computations, a lot of fractions. So tangent of 2 theta, if you copy down your formula, is 2 tan of theta over 1 minus tangent squared theta. Okay, so this one you actually didn't need to sketch the triangle. If you recognize that tangent is just the reciprocal of this, you could just say tangent is -1/5, right? So tangent of theta is -1 over 5, right? The reciprocal of cotan. All right, so plug it in and simplify, okay? So this really works on your algebra skills more than anything else. And I have to square it, so don't forget to square this. You're going to get -2 over 5, 1 minus 1 over 25. And this is a complex fraction here, right? What I would do is multiply top and bottom by 25. Okay, the LCD of this denominator, and this denominator is just 25. Okay, so 5 goes in 25 5 times. You're going to get -10. 25 times 1 is 25, minus 1. And your fractions are a little bit less intimidating now, right? You're going to get -5 over 12 when you reduce. So that's pretty much it for your double angle formulas. I would just go back and look at them, keep them as a reference when you're doing your homework. When you're doing your homework on problems 11 through 20, it says use a graphing utility to approximate the solutions on the interval from 0 to 2 pi. If possible, find the exact solutions algebraically. I will tell you all the solutions are able to be calculated algebraically. You can use the calculator to verify, but you still have to show your work by hand like I did over here. I'll also make that announcement on the Google Classroom.